Okay, in this last video about logarithms, I'm going to deal with some applications. But first, the last anagram of the day, editor. I'll give you a hint. What do editors do? Okay, let's talk about acids and bases, sound, and earthquakes. There's an equation for the pH of a solution, which is negative the log to the base 10 of the concentration of the protons in the solution in moles per liter. You've probably heard of pH. So let's say, for example, the pH is 5.6, and we want to calculate the concentration of the protons. That's minus the log of the proton concentration. Before we can solve this equation, we've got to multiply both sides by -1. So I get negative 5.6 equals the log of the proton concentration. And then I can use the definition of a logarithm to get 10 to the negative 5.6 equals concentration of protons, because negative 5.6 is the exponent to which the base of the log, which is 10, must be raised to give that number. Now if you do that on a calculator, it turns out that that is equal to, let's see here, 2.5 times 10 to the minus 6, which is micro moles per liter. I won't do an example where I give you the proton concentration, because I think any dummy can take the log of it and make it negative. Okay, let's move on to sound. The difference in two sound levels in decibels is 10 times the log of the ratio of their intensities. So let's say we're comparing the loudness of a chainsaw to the loudness of average traffic, which is about 85 decibels. And the ratio of their intensity is about 300, so that's the log of 300. So to get the loudness in decibels of the chainsaw, it's 10 log 300 plus 85, which works out to be 110 decibels. So for that kind of a sound, you probably want to wear some ear protection. And finally, for earthquakes, the difference of their magnitudes is the log of the ratio of their intensities. So let's say we have an earthquake of 6.5, which is fairly intense and pretty deadly, and we'll subtract that from one that's 8.1, an extremely dangerous earthquake, create a lot of damage, is the log of the ratio of their intensities. So that being 1.6, and 10 to the 1.6 is the ratio of their intensities. You can work that out, it's about 40. And then in conclusion, I can make a few generalizations. For example, every time the concentration of protons goes up by a factor of 10, because of this minus sign, every time this is times 10, this will go down by 1. You can try that with some numbers. So for example, if it goes up by 1,000 times, the log of 1,000 is 3, so this will go down by -3. Over here, every time this goes up by a factor of 10, the log will go up by 1. So the difference in the decibels will go up by 10 decibels. So again, if this is 10 to the 3, that's the log of that is 3. 10 times 3 is 30, so this would go up by 30 decibels. And over here, in general, every time the intensity goes up by 10, the difference in their magnitudes will go up by 1. So if this was 10 to the 4, the log of that is 4, so the difference in their magnitudes would be 4. So you can use those formulas to answer different questions, and you'll probably get some in your math books. All right, in conclusion, what do editors do? Well, you could say they redo it, or they tell you to redo it. On a side note, you could also spell dieter, so maybe they diet, although I think the proper spelling is with an E there. All right, it's been my pleasure to do this series on logarithms. Stay tuned for the next series. All the best.